Welcome to our Metasploit tutorial, where we'll give an insight into the security framework called Metasploit. Metasploit is an open source tool and is used to streamline the process of exploiting vulnerabilities. In simple terms, it helps find weaknesses in computer systems, networks, and applications. The aim of this tool is to test and strengthen a system's defenses. Firstly, let's delve into the basic structure of Metasploit as shown in the figure on the screen. Metasploit can be used via various interfaces, namely the console, msfconsole, command line interface, web versions, and various GUI tools. Some of these will be showcased later in the video. Metasploit has a numerous number of modules, with the key modules being payloads, exploits, encoders, NOPs, and AUX, which will be explained later in the video. A module performs a specific function within the Metasploit framework. The libraries consist of Rex, MSF Core, and MSF Base. Rex is a networking library within the Metasploit framework. It provides a set of modular components for handling common network tasks such as working with sockets, managing sessions, and handling network protocols. Rex helps developers in a way that they don't have to worry about the intricacies of network communication and can focus on building functionalities. MSF Core is the core framework that forms the foundation of Metasploit. It provides essential functionalities and components needed for proper functioning of Metasploit modules. MSF Base provides a basis for configuring and initializing the Metasploit environment. It ensures that the user has the proper settings and environment it needs to operate within the Metasploit framework. Together, these components provide a modular and extensible framework. Now I will show you how to set up the Metasploit framework in a Kali Linux environment. So let's make sure everything is up to date by inserting sudo apt update. So once this is done, you should update all your packages. I'm not going to do that right now. I will just show you how to install the Metasploit framework, and you do it via the following command. This ensures that it installs the Metasploit framework on your Kali Linux system if you've not done so already, and this can also be used to update the Metasploit framework. Once this is done, I'm just gonna clear the view. And now we are going to start the PostgreSQL database service, which is a database management system which you will need for your Metasploit framework to run. Now we will start the MSF console. Once we're in the MSF console, we'll check the status of the database connection using the following command. We can see that it's connected to MSF and the connection type is PostgreSQL. In some cases, it will not be connected to MSF yet, and what you have to do is exit the MSF console and use the following command in order to initialize the Metasploit database. And as you can see, it's already configured in my case. But if it was not, then now it will be, and you can go back to the MSF console. And if you type db status again, you will see that it is now configured to the MSF database. You are ready to use the Metasploit framework now.
So we will now go over the main components of the Metasploit framework. So the Metasploit console is the central component when utilizing the Metasploit framework. This console can be used with the msfconsole command to run it from the terminal. The primary interface for interacting with the various Metasploit framework modules will be the console. And within the Metasploit framework, modules are discrete parts designed to carry out a particular function, such as, for example, brute forcing an attack or finding a vulnerability. So first, before we go more into depth about the different modules, let's first define a few key terms that will reoccur during this tutorial, namely vulnerability, exploit, and payload. So the term exploit refers to a section of code that takes advantage of a weakness in the target system. Vulnerability refers to a defect in logic, in design, or in code that impacts the target system. So for example, when a vulnerability is exploited, private data may be revealed or the attacker may be able to run code on the target system. Vulnerability will be exploited by an exploit. And nevertheless, a payload is required if we want the exploit to achieve our desired outcome, which could be, for example, gaining access to the target system, reading private data, etc. So the code that will execute on the intended system itself is called a payload, and this refers to the last term. So we will now go over the modules and the categories which can be interacted with from the MFS console. We have an auxiliary module, so any supporting modules such as scanners, crawlers, and fuzzers can be accessed through here. You can access the module by typing in auxiliary in the console, which shows you the list of the components you can access. Next, we have the encoders module. Encoders will allow you to encode both the exploit and the payload in such a way so a signature-based antivirus program will miss them. So the way this works is that antivirus and security programs that rely on signatures have a database of recognized threats. And threats are identified by cross-referencing suspicious files with this database. If a match is found, an alert is generated. And as a result, the success rate of encoders may be limited because antivirus programs can run extra checks. Next, we have the evasion module. This is similar to the encoders module. However, although encoders will encrypt the payload, this does not mean that they are trying to directly circumvent antivirus software. However, evasion modules will attempt that specifically, albeit with varying degrees of success. So we have the exploits as well, which we mentioned previously. So these modules, they take advantage of a weakness in the target system, and they are organized by the target system. We have the post module, which are useful on the final stage of the presentation, of the penetration, I mean, for testing process. So the post exploitation, basically. And then we have the no operation modules. So the NOPs, they are utilized as a buffer to achieve consistent payload size. They are represented by the code 0x90 in the Intel x86 CPU family, which causes the CPU to basically stop working for one cycle. So next up we have the payloads module. So as mentioned previously, exploits will take advantage of a weakness in the target system, but a payload is required to get the intended outcome. And obtaining a shell, inserting malware or a backdoor into the target system, issuing a command are a few examples. And while executing commands on the target system is a crucial first step, it is preferable to have an interactive connection that enables you to type commands that will be carried out on the target system. So payloads have 4 distinct directories. We have the adapters. They are used to transform a single payload into a different format, which is basically wrapped by the adapter. For example, typical single payload, for instance, can be wrapped around a PowerShell adapter to create a single PowerShell command that will carry out the payload. Next up, we have the singles. These are self-contained payloads that can run without the need to download an additional component, such as notepad.exe, for example, or adduser. We have the stagers, and they are in charge of establishing a channel of communication between Metasploit and the intended system. This is especially beneficial when handling stage payloads. So stage payloads download the remaining payload, so the stage, after first uploading a stager to the target system. This has certain benefits because the payload starting size will be smaller than the full payload sent at once, which comes to the less directory, namely the stages. And so basically the stage manager downloads these payloads. And in this way, you will be able to use larger payloads as a result. So as previously mentioned, the console will be the main interface of the Metasploit framework. The console can be launched from the terminal by typing in the msfconsole command. This can be typed in the terminal of the system where the framework is installed on. And here we can see that the framework is being launched right now, and we just have to wait until this process is completed. Yes, so now the framework is launched from the terminal, and we can recognize it by the MSF6 characters in front of the prompt. So the console can be used like a regular command line shell. For example, we can type in the command ls, and this shows a list of the contents of the folder from which the framework was launched from. There's also support for tab completion in the console. This is a key feature. Later on, when working with different modules or utilizing different Metasploit commands, this will be very helpful. For instance, we can type in the letters HE, and when we click on tab, it will autocomplete the command, after which we can execute it by entering the command. Yes, so now you can see the command is executed, and we can in turn use the clear command to clear the terminal. So important to note is that because the console is context managed, all parameter settings, if not set as a global variable, will be lost if you switch the module you've chosen to use. So let's try an example to explain this. For the example, we will use the EternalBlue exploit, which is an exploit developed by the US National Security Agency for a vulnerability affecting the SMB-v1 server on numerous Windows systems. So the SMB refers to server message block, and this is widely used in Windows networks for file sharing and even for sending files to printers. We will use this exploit by using the command use, and then we have to navigate to the folder where the command is basically saved. We can use again the tab completion or the tab function to complete our command. So we go to exploit, Windows, and then we go to the SMB folder, whereafter we can choose the exploit. And here it's the EternalBlue exploit. So when we play on enter, it says that no payload is configured yet, but we can also see that the exploit is activated because the prompt has changed. You can see it in the red lines, which that this specific exploit is now activated. So while the prompt has changed, you will notice we can still run the commands previously mentioned. For example, we can still use the clear command. Yeah, so that clears the terminal. So now by typing in the show options command, we can see all the related functionalities or options to the exploit we have chosen, in this case the EternalBlue exploit. In this example, it shows that this exploit will require reset variables like airhost and airport as named here. And also the show command can be used in any context followed by a module type, for example, show auxiliary. This lists all the available modules for this specific exploit. So for example, we can type in the show payloads command. This shows a list of payloads that can be used with the MS70 EternalBlue exploit. If used from the msfconsole prompt, the show command will list all the modules. So the use and show option commands we have seen so far are identical for all modules in Metasploit. Also, further information on any module can be obtained by typing the info command within its context. Alternatively, you can use the info command followed by the module's path from the MSF console prompt. So for example, we can do info, and then let's select the exploit we have selected right now from its folder path, and then it was MS17, and then EternalBlue. So the info is not a help menu. It will display detailed information on the module, such as its author, relevant sources, etc. You can leave the context using the back command. So we type in back. Yes, and now we can clear the terminal again. So one of the most useful commands in the msfconsole is the search command. This command will search the Metasploit framework database for modules relevant to the given search parameter. For example, we can type in search ms17010, which was the same exploit we just used as an example. And also you can conduct searches using SVE numbers, exploit names, or even target systems. The output of the search command provides an overview of each returned module. You may notice the name column here, which already gives more information than just the module name. You can see the type of the module at the beginning, such as exploit, auxiliary, etc. And the category of the module, such as scanner, or in this case, a specific exploit. And you can use any module returned in a search result with the command use followed by the number at the beginning of the result line. So for example, if you want to use this, exploit, the line number is 1. So we can just type in the command use 1, and then we can see that the exact same exploit is activated right now as the one mentioned here. Another essential piece of information returned is the rank column mentioned here, and this is the rating of the exploits based on their reliability. The table in the screen provides their respective descriptions, and as you can see, there's different ranking for different exploits, and it's all based on how reliable this specific exploit is. Additionally, you can direct the search function using keywords such as type and platform. So let's first back from this exploit and clear the terminal before we continue. So for example, if we wanted our search results to only include auxiliary modules, we could set the type to auxiliary. So we type in the search command and we can specify a type like auxiliary tablets, for example. And now you can see that only auxiliary modules are returned, and also the ones where the word telnet is specifically mentioned. So one important thing to remember is that exploits, they take advantage of a vulnerability on the target system. And this may lead to unexpected behavior. For example, a low-ranking exploit may work perfectly on the target system, and an excellent ranked exploit may not, or worse, even crash the target system. So it really depends on the target system and also on the exploit itself, and not specifically the ranking.
Okay, so now that we are all familiar with the components of the Metasploit framework, we will have a short look at a demo for practice, and we strongly encourage you to follow along in order to learn a lot about Metasploit and how vulnerabilities are found and exploited in practice. And we will begin with the resources that we will need for this demo. First of all, VirtualBox, and then we will have a Kali Linux image, which will be the attacker, and a vulnerable Windows image, which will be the victim in this case. And they will be set up in the following way as to emulate a scenario where an attacker has already gained initial access to the network and he is looking for more vulnerable machines to exploit. And we will have the Windows VM and the Kali Linux VM running inside of VirtualBox on the host and connected via a virtual bridge. It's important to keep in mind that we will have the Windows VM at the .15 IP address and the attacker at the .4 address. Before we start with the demo, it's really important to understand that you should not be doing this unless you own the machines that you are working on or you have explicit permission to attack them, because otherwise you could get into real trouble. And here we are inside of VirtualBox with the Windows VM and the Kali VM running. This is the Windows VM over here, but we'll put that away for a second. And this is the calling machine that we have running. And if we assume that we are an attacker that has just infiltrated the network, we need to first figure out what hosts are on the network that are up and that can be attacked possibly. So what we can do is use nmap for this, which we have learned about in the lectures. And we can use it the following way. So what this does is it runs an nmap scan on the range from 10.0.2.0 to 255. We're using the T5 speed in order to have to wait less, but ideally you wouldn't be using this as an attacker because it's very obvious. And we're also running a stealth scan, so it is harder for intrusion detection systems to log the scan that we're doing. And we can quickly take a look at the available hosts here, and we can see that we have quite a few. .1, .2, .3, and I think the most interesting result is the .15 address, which has quite a few ports open. And if you were familiar with the service message block service from Windows, you would know that these ports are associated with it. And also that service has known vulnerabilities that were discovered in the past. So what we can do in order to discover vulnerabilities on this host, we can use scripts that come already packaged with nmap. And we can do so the following way. Specify the IP address of the target and the speed, and then the script that we want to run. This takes a while, so we'll be back once this is done. Okay, so here we are back with the results of the nmap vulnerability scan that we just ran, and we discovered a remote code execution vulnerability in the Microsoft SMB server, which is also labeled as vulnerability MS17-010. And as we can see, this is a critical remote code execution vulnerability with a high risk factor. So this may be something that, as an attacker, we're interested in pursuing. And what we can do is start the msfconsole. And what we're going to do is search for this vulnerability, see if Metasploit offers any already prepackaged exploits to use. So we're going to search for MS17-010. And as we can see here, we discover an exploit called EternalBlue. This is a famous exploit that has been used in the WannaCry ransomware attack. And we also discover a scanner for this. So if we wanted to make sure that our target is vulnerable as nmap reported, what we can do is use 3, which will essentially select this scanner to be used by Metasploit. And now we need to show options to see the options that are required by this scanner. And we can see that our hosts is not set to anything and it is required, so we need to set it. What we're going to do is use the command set g in order to set globally the variable our hosts. And we are going to set it to 10.0.2.5 because in the meantime I changed the machine from the .15 address to the .5 address. So now we have that set, so we can just use run. And what we get returned is the fact that the host is likely vulnerable to the MS17-010 exploit. So now that we know that our target is vulnerable to the EternalBlue CVE, what we can do is look back at our search results and we see that number 0 is an exploit for the EternalBlue CVE. So what we can do is use 0, which will switch to the exploit. We can show the options. And we see that our host is already set because we set it globally. And we also see that the payload is Windows x64 Meterpreter reverse TCP. We're going to set it to a simpler shell using the set command. Set payload, and we're going to set it to Windows x64 shell, and then reverse TCP. Well, all that remains is to run the exploit against the target. After a bit of time, the exploit has finished, and as we can see, it seems like we got a shell into the Windows machine, and we can use the command whoami in order to prove that the shell is working as intended. So a quick recap of what we have shown in the demo. We started by using Nmap to scan the network to identify vulnerable hosts. Then we found vulnerabilities in the hosts using Nmap. Additionally, this can be done using Metasploit as well, which we use to confirm the vulnerability. And lastly, we exploited the vulnerability by searching for an appropriate exploit, using the exploit against the target, and lastly, getting the shell in order to execute arbitrary code on the system.